All right, I wanted to welcome everyone to our event. We started October 2016 and we're still going strong. And I want to thank you, first of all, for being here on this lovely day. And we learned that if it's a holiday weekend coming up, some people like to go on vacation. So I appreciate that you all are here, eager to learn and get excited about this topic. So there's been a few things in the news lately that I think are kind of very topical. I think everyone's kind of seen that Google Duplex demo where they show Google actually reaching out and having a conversation with a human. So if you take a few steps back from that, the original computers, how much can you do with a computer in a room? You start hooking it up to things, you hook up sensors, you get it on a network, the amount of data you can get into it, the amount of power and like what it can do increases drastically. And we just keep going from there. We lower the bar for connectivity. We go from hardwired computers to protocols to internet to APIs. And now we're becoming to the point where we're not just doing humans talking to computers on a terminal, humans using a UI. It's computers like literally in our own language. Like you don't have to be a programmer, you don't have to be trained how to use an app. The computer can actually speak in a language that like you were learning as a little child, and the computer is able to like follow along with that, and like the potential is tremendous. If you think about the amount of data you can get and the processing you can do, now that the computer has this other method to actually talk and gather information. So it's super exciting. Conversational AI is an amazing space. We have two great presenters for you today in that space. So our first speaker actually is Jeff Smith, who was at edXIA at one point, and now is at IPsoft, who's the head of Amelia. He's going to give us a presentation on questioning conversational interface. So give Jeff a chance to come up here.
Alrighty, folks. Hi. As Alex said, my name is Jeff, and I want to talk to you about some general issues in conversational AI. So for background on who I am and what perspective I come from, I'm primarily a machine learning developer by training and by most of my experience. And so my focus is on how do we build machine learning systems that operate at scale. The book you see here pictured records my thoughts on that. It's a lot of design patterns for building machine learning systems that operate in real world environments and do useful work. The experience I'm going to talk about mostly tonight is based on my experiences in deploying AI technology, primarily conversational AI technology, to real-world enterprises, and so I've done this work across a large number of industries: ad tech, bioinformatics, proprietary trading, and now focusing in on these specific enterprise AI applications of things like customer service and scheduling meetings and calling people on the phone, getting them to deliver your drive thing. In this talk, I'm going to assume some things about you, which are a little bit different than pretty much any of the previous talks you might have seen me give if you've seen my stuff kicking around the internet. I'm not going to presume that you're necessarily a developer, but you are interested in the technical properties of a conversational AI system. And so what I want to talk about is maybe you as a user of a conversational AI, but more often you as someone who is thinking about developing and operating or purchasing and operating a conversational AI system of some sort. So you're going to be responsible in some way or affected by the consequences of the properties of the system that is responsible for interacting with you in a conversational manner. And so I want to just dig into what are some questions we can ask about a given AI implementation. And so this is all questions, no answers. You're going to have to look somewhere else for the answers. I hope you can find value in that, because I think there's a lot of really interesting questions you can ask given the importance of conversational AI right now. So let's begin with knowledge. So this is a subset of the functionality within an AI system. We're concerned with what an AI knows. So the first and most important question I would ask of any conversational AI is, does it remember? And so there's all sorts of forms of memory out there. So the most basic and simplistic conversational AI systems you'll see going back decades have absolutely no memory, right? And so that you make a single utterance and you get a single response back. We have a much higher expectation that's come about pretty recently, and so we can tell someone, tell conversational AI that my favorite color is blue, and then ask later what is my favorite color. This becomes really germane in contexts like X.AI, where you have meeting preferences. I like to go to the coffee shop. by my home. And so these are relatively straightforward to verify, but it's really important to know what does the conversational AI remember. So this is our sort of base level concern. After that, let's ask the complete opposite question. Is this AI capable of forgetting? At this exact point in time, we're just days past the GDPR going into effect. And so any of you who work in tech have been preparing this for months, and you're aware that there are all sorts of new requirements for us to drop data from our systems to be able to make sure that people don't have access to particular things. And this is really important because most of the data management paradigm that a lot of large-scale big data technologies that we've been using in startups and larger organizations for the past several years are really originated in an ad tech context in which data was largely never discarded. And so we have whole paradigms of engineering that are based around immutable, write once, never erase data. So this is a new world we're operating in. So does your AI actually have the ability to forget something, like something you told it that you don't want it to remember anymore? Another area of knowledge is just knowledge about the world. Can you ask an AI, is it sunny today? That might be off topic if you're scheduling a meeting, but it might be really germane if you're talking to a smart speaker and you're trying to plan your day and grab an umbrella. And so that you see, there are particular organizations that have invested deeply within having this sorts of knowledge. I would call out Google as probably the obvious example of the largest investor into the organization of structured knowledge, but if you do not have access to a resource like that, you can find that many conversational AI interactions are quite thin and shallow, and so there are all sorts of regular questions you could ask a human being, like who is the president, what is tomorrow, is it Thursday, that you cannot actually interrogate a given conversational AI about. And this starts to define how the user interaction works. Another area of knowledge I'm interested in when I interact with an AI is does it know anything about me? And so this is not just necessarily things I've explicitly stated, but rather things which can be observed or state which exist somewhere else in the world. So for example, have I filed a return claim for some outstanding product, and am I thus now contacting this customer service conversational agent for the purpose of addressing some issue with that return claim around a defective product? And so this is another thing which we can probe for, right? Does the AI happen to know about the current state of me, and doesn't have any concept of a user? A large number of fairly simplistic throwaway applications that you see in things like smart speakers or even on various bot platforms don't necessarily contain a deep and rich concept of a user, and so that they obviously have no knowledge of you as an individual, and there's a whole suite of interactions they're fundamentally incapable of performing. Okay, so those are the basics around what's inside the AI's brain. What is the level of knowledge it has? Let's move on to understanding. So here, what I really want to be talking about is an AI's ability to take a given utterance that is just a sequence of words and turn it into meaning that it can be acted upon. So the first one I want to throw out there is, does it understand names? And so this is sort of basic capability that all of us as humans have. But ends up being a little bit more complicated within the context of encoding a conversational AI. Imagine if you named your child chair or light bulb, or for that matter, I pity so greatly any person who happens to be named Alexa in 2018. And names are complicated, and they don't necessarily follow rules, and they vary a great deal across cultures and languages. And so the ability of a conversational AI to understand where your name stops and where other words in the sentence begin is actually something that can be quite complex to verify. Names are important, but we actually refer to each other by pronouns all the time. And so there's a core capability within natural language understanding that's a very active area of research that you can see present or absent within various AI implementations. And so that capability generally goes by the name of co-reference, which simply means that if we say that I greeted Alec when I walked into this meetup tonight, and then I talked with him later, who is him? Do we have the ability within that conversational context to retrace back and resolve that pronoun into a canonical entity represented by a proper noun, Alec, or something like that? This is a really hard problem. Just because it's so easy for you as a human, it becomes quite challenging for AIs, and so that you can find even AIs that are implemented with co-reference capabilities, in many complex dialogues, we as humans do not necessarily express all that information. A past memory of mine is trying to understand who exactly she is in a conversation that includes 3 women and 4 men scheduling a meeting, which she will be referring to. There's actually no way to resolve that. And so this is a fundamental challenge to language that shows up a great deal when humans are talking to computers and are prone to blame the AI for the fundamental ambiguity of human language. Okay. So we talked about we talked about knowledge, but knowledge isn't static. We improve our knowledge over time. And so this capability is called learning. And so this relates to, of course, the field of machine learning. So when you look at artificial intelligence literature, you will see various classes of intelligent agent. And so the simplest one that we're concerned with tonight is an intelligent agent, which means it has some knowledge base on which it can make decisions. A higher level of agent is an agent that learns. So let's talk about learning. So does the conversational intelligent agent learn? Can we prove that when given access to further instances of data through interactions with users or whatever the case may be, can we see improved performance in the AI? This is not a trivial question, that a large number of technologies in use today, we don't have any way of verifying that as a user. If you ask your smart speaker or you talk to a chatbot, can you actually observably see some measure of performance improve over time? And there's also reasons why we would want an AI to be capable of learning continuously. So to talk about one of those in particular, let's ask about how fast does it learn? And so what I want to talk about here is the concept of a concept. So in machine learning, we have an entity called a concept. A concept is a collection of features, that is, derived representations of raw data attached to some sort of class label. So this is the thing we're trying to predict. Does someone want to open a new account? So that's an intent. And we have all these features that come from the utterance. And the person said this and that and the other thing, and they do not have an account. Concepts are often not stable. So there's one of the hardest problems I've encountered within engineering real-world AI systems is that concepts drift. And so on a given day, for a particular application, we may find that, let's say the classification is something like propensity to obesity. So we're trying to determine if someone is likely to become obese within the next 10 years. And so we have a feature vector that has eats Domino's pizza on a daily basis, drinks 2 liters of Mountain Dew on a daily basis, and the AI can learn that concept. And so if it hears you talking about Domino's pizza and Mountain Dew all the time, it collects up that class label, and then maybe it's going to try and perform a corrective action, like recommend that you eat more healthfully. But we can imagine that someday Domino's comes out with a beautiful vegan pizza that's much lower calorie and has a higher vegetable content and lower meat content, and there is 0-calorie diet Mountain Dew. Suddenly that concept is no longer valid, and so the AI must be able to respond to that. So the observance of, when we talk about observing how fast AI can learn, we're talking about responding to changes in the real world, because the real world is not a static thing, so the knowledge base can no longer be static. For our AI to learn, we presume that there must be some way to teach an AI. And so there are multiple paradigms for teaching an AI. The one that gets talked about a lot these days is supervised learning. And so in supervised learning, we're having a human encode a given class label. And so we have someone who says, this particular email is spam. This user is now trying to reset their password. Use cases like this. There are other paradigms of learning, and they're becoming increasingly important. In particular, I would point out unsupervised learning is one of the most important techniques being explored within NLP research right now. So that means that without having humans label any classes or inject any intelligence, we can actually just have artificial intelligences read large corpora of language data. So they can read all of Wikipedia, and that will give us some sort of large-scale model of how relationships are structured in English without ever having to require a human to annotate anything. It's a really powerful technique, and we're starting to see it in universal language models become generally applied. And as an operator of a machine learning system, I sort of want to know if this is one of the interaction paradigms I can use to train the AI. There's also another form of injecting knowledge via teaching that's really interesting, that is starting to see some really exciting results. So you see example problems like games and video games, famously like AlphaGo beating the world's Go masters. And that's reinforcement learning. So in reinforcement learning, we're not necessarily teaching AI pure concepts, but rather we are rewarding an AI for the actions it takes. We're getting closer to the goal. We're getting somehow closer to the maze or something like that. And so in a transactional kind of conversational AI context, this means that we're trying to simply reward the AI for getting bookings, for closing out the conversation. This represents a possible source of data which does not require the investment in the same amount of human annotation, which is powerful if your problem context suits that. So if we can teach an AI, it really matters what it has been taught. And so most of the research within natural language understanding is focused on general applications, trying to understand English in particular. And so most applications of AI are domain specific. We are trying to schedule meetings. We are trying to recruit people into a company. We are trying to resolve a customer service dispute. We are trying to check the weather while someone is driving, so on and so forth. So being able to understand what an AI has been taught and what that knowledge is really important, because there's possibilities that there are things within that knowledge base that we don't necessarily agree with. And so this dovetails back to the conversation we were having just before this talk about where is bias injected into an AI. And so bias is often injected into the knowledge base, so that humans' beliefs about particular types of people, whether that's race or gender or sexual orientation, we can find those in the data set, and we can see if in fact biases have been introduced, if the AI has particular beliefs about a person encoded in the structure of the knowledge it uses to reason about the world. Okay, so I brought up a number of problems and difficulties and ambiguities, and so I want to bring up the general concept of certainty. In particular, a lot of software engineering technology is based around the concept of having an absolutely perfect state of the world, of believing in a certain level of truth, that if it compiles, it must be correct, things like that. Conversational AI doesn't really share that property in a lot of contexts. So can an AI get confused? Certainly, semantically that is true. Is that true within the implementation of the conversational AI itself? Is its state probabilistic? Is its memory full of things it definitely knows, or has confidence intervals? And I'm 80% confident that this person really likes Sam Adams beer, but it's like a 20% probability that maybe they prefer Heineken. This is not a guarantee out of the box, and in fact, the vast majority of databases don't provide a good way of materializing something like uncertain knowledge. And so as we rise higher and higher up the stack, expressing probabilistic knowledge throughout an entire application's levels of implementation is hard, and is frankly quite uncommon. So if we have confusion, how do we resolve it? So this is a fairly sophisticated capability that we're really only starting to see the beginnings of, and I think it's increasingly important for real-world use cases of conversational AI. And so if you imagine commerce applications within a conversational AI where you're saying, purchase this item in this amount, it's really important to make sure that we got the number 15 right, and don't order the person 50 rolls of toilet paper when they only wanted 15 rolls of toilet paper. And so encoding uncertainty is a great way to then later resolve it through things like clarifying questions, which again is an interaction that may or may not be present just depending on the implementation. Okay, now I want to talk about different natural languages. There's a sort of high-level context I want to establish, is that we as a species, as human beings, know differing amounts about different natural languages. That is, we know a whole lot about English, which has billions of speakers. But we don't actually know that much about, say, Finnish, which has a few million. And so our knowledge as a species informs what are the properties of technologies we can implement that take advantage of that knowledge. So does the conversational AI understand my language? It's definitely not true out of the box for all sorts of technologies in this case, whether they're textual or vocal. There's a large number of languages in the world that are spoken by millions of people that are not necessarily the focus of the relatively small group of large technology corporations building the underlying fundamental technology that allows us to perform things like this. So for example, if you wanted to find a Farsi co-reference data set to train a model, you might find it challenging because while co-reference is a relatively well understood algorithmic problem, it's based on having hundreds of thousands, if not millions, of training instances that have been accurately annotated, which may not exist in the example of Farsi. So another really important question is, does it understand my whole language? And people tend to gloss over this in marketing bullet points. And so this comes up in various areas. So ranking things in terms of like global language data assets, we probably know the most about English of any language within history. And then from an NLP perspective, probably number 2 on that list is Chinese. If you happen to speak one of several Germanic languages or Scandinavian languages, you might use a very large number of compound words which are dynamically combined in a way that doesn't really correspond to an English language concept. So when structuring up the natural language understanding functionality to parse those sentences, when you have these multi-part compound words, if that concept doesn't exist in English, there may not be code for it to tie up to within parsing code that exists within the conversational AI itself. Similarly, a fairly large number of languages have sophisticated concepts of formality that don't exist in English, and so English is a sort of bad base point to model those properties of language. And so, similarly to before this, we were talking about French and its use of gender within language. That's another property that doesn't exist within every utterance within a given language. In Chinese, for example, he and she are both ta. And so if you're starting with Chinese as your base language, you will find French very challenging to model appropriately, and your conversational AI may ultimately be reducing every E and L to ta. Which brings up, how did it learn grammar at all? So grammar comes from somewhere. It comes from deeply well-structured data sets that have been annotated to encode knowledge about how humans express themselves in language. And so for your given language, where did that data set come from? How big is it? And how well does it actually encode the sophisticated concepts of your language? And in particular, was it developed by people who have no direct knowledge of your language, and so it may not have concepts like formality or gender or things like that. Here's a great one that hits everyone here, which is, does it understand my spelling? A large number of the applications that we're trying to deploy conversational AI to have imperfect user interfaces. So one really common one is a plane of grass that you're screwing with under thumb on the way to the subway, and then you're swiping around and you're hoping that it gets the spelling right. But if it says Alex instead of Alec, is that going to cause a problem? Is it going to be able to resolve the entity? So this is a really key issue that comes up both within written form because of autocorrect and typos and things like that primarily in phones, but then also within speech recognition. So when we have transcripts of proper nouns that are then transcribed as common nouns. I've talked about voice a lot, but I just want to bring up some of the very specific, very hard problems of voice because I think they're really interesting and I think they're really prevalent. I think conversational AI in voice is an incredibly interesting space to think about, but there is a sort of challenge for us within industry and then, of course, back in academia as well, to be able to find ways to deal with unique problems of voice. First off, can this conversational AI speak? We all are familiar with the applications of having smart speakers, why you want to have your car talk back to you when you're trying to find directions. Its ability to speak can vary greatly, again, by language, by use of proper nouns. And so there's a lot of specific details I'm going to dig into. So right off the bat, can it pronounce my name? I happen to be named Jeff Smith, which is the fake name they put on credit cards. It is the absolute perfect training example. It's super well supported. My wife's name is Jia Yifan, which is absolutely not within any English language corpus. And so she's going to have a really hard time interacting with a conversational AI that needs to pronounce that name in a comprehensible way. so she's probably going to need to use an English name like Leslie, which is what she does. So next, beyond speaking, we also care about listening. And this is where we really get into some pretty cool tech. For those of you who haven't spent any time researching local technology, this part of the application is called an automatic speech recognizer. It's an area that's been under research for decades. Classic designs have a large number of distinct subproblems within them that have been fine-tuned over just enormous amounts of human labor. And then there are some fairly popular techniques pioneered by places like Google and Baidu to use neural networks and deep learning technology to build new classes of automatic speech recognizers. The researchers will typically claim that automatic speech recognition is at human equivalence right now, but that's good news and bad news because we as humans aren't perfect. The best statistics around humans' ability to transcribe speech in artificial academic scenarios is in the 80th percentiles, which is a lot of incorrect words when compared to something like typing. And so this is a real challenge and a major area of investment, and for the most part there's a fairly small number of organizations that are pushing the bleeding edge to get us to fundamentally greater capabilities. If you're taking the persona of someone who's developing conversational AI to be deployed to a local platform, you have to presume that there are going to be errors in transcription in the case of proper nouns, but also just in the case of regular words. And so an additional complexity is that the idea of a concept here, right? So automatic speech recognizers are trained off of recordings of people speaking and transcripts of what they said. Those recordings come from particular contexts. The properties of those contexts and the resulting transcriptions formulate a sort of concept. And that concept may not be valid in the environment that you're in. In particular, it's super different to imagine the properties of what an automatic speech recognizer has to do within, if you're walking down a New York City street and you hear a jackhammer versus when you're in a car versus when you're directly on a phone on a Bluetooth headset. These are different situations in which an automatic speech recognizer should do something differently. And there are techniques to adapt to them, but there's still, I think, a whole bunch of low-hanging fruit around richer capabilities here in terms of us developing more sophisticated automatic speech recognition techniques that dynamically adapt to the environments in which we're deploying them. So I'm going to guarantee you that your automatic speech recognition system is going to mishear. It's not going to properly transcribe what you said to it each and every time. And so the question is, what is it going to do at that point? And so this is similar to the spelling example, but instead it's a transcription error in some way. And so this is really important if we're doing something like touching money or something else of value, like someone's time or their commitments or something like that. This is sort of a responsibility of the natural language understanding system. The natural language understanding system has to be built with the awareness that it's going to be operating on speech data and not textual data. The sorts of errors we see being fed into natural language understanding systems are super different if we're talking about a vocal context versus a textual context. And adapting to those errors is a really hard problem. Another question I want to raise about a conversational AI is, can it recognize my voice? One of the largest applications that I think a large number of people are pursuing within the conversational AI space is transactions. We want to perform commerce on these new platforms. The same thing we want to do on every new platform. So that implies that we have some authentication mechanism and the ability to recognize that that is Jeff talking and not his parakeet. But unfortunately, as you can see right now, that smart speaker technologies as later actually will respond to the household parrot, which can learn to then order birdseed and things like that. Because security is hard. Security is not my favorite topic, but it just pops up all over the place with this particular problem. And so I want to run through a few things which keep me up at night. Maybe they should keep you up at night as well. The first is, will it respect my privacy? This is a user example. This is super germane to each and every one of us who are interacting with conversational intelligence systems that in some way capture your personal information. If you are dealing with, say, the insurance customer service agent, and you're providing things like your social security number, your date of birth, your policy number, you're in a returns context and in customer service, you need to provide a credit card number. your personal information, keeping it private to you, is incredibly important, and it's not directly visible from an interaction with an AI. There's no way for us to directly inspect this as users, and so this is super important for those of us who end up operating conversational AI systems, being able to provide good guarantees. A related question is, can its mind be read? This is sort of overlapping with another mentioned GDPR. We have knowledge bases inside these conversational AIs. They record out everything that they've ever conversed with anyone about. And so that means if you've shared all of your important personal details, where is that data stored? Who is it accessible by? Are incredibly important questions for you to ask if you're interacting with a business which operates a conversational AI. And then my last little area of concern is, beyond security, I'm concerned with infrastructure. And this is motivated on my personal experience as someone who builds machine learning systems and tries to help others do the same. First, can a conversational AI handle being busy? So we as humans are implicitly single-threaded. We do one thing at a time, which is great. And one of the key areas in which an intelligent agent can supersede human capabilities. The conversational AI can talk to many people at once. But what happens when it talks to many people at once? Does it keep my data secure? Or is it possible for data to cross conversations? Does response time go down in response to increasing load? Or does it continue to have the ability to fulfill all of my requests, even if I ask for, I want 1 million song recommendations, and someone else wants 1 million song recommendations? Where do we hit the limits of those conversational AI capabilities that are pretty much uniformly being deployed in a highly concurrent format? And then the last question I have here is what happens if the AI gets hurt? That is, what happens if there's a fault in the infrastructure, in the code itself? What happens if the execution of this program in some way gets off track? What are the guarantees I can still hold to? So for example, if I have a headache, if I twist my ankle, if I break my arm, I can still tell you my name, my date of birth. I can probably do useful work. I can maybe show up to the office and get things accomplished. Conversational AIs are built on machines. They don't necessarily have these same properties, and so that when there are faults in those systems, we may or may not have the ability to provide the services that we were expecting before, which may sound completely unimportant if you're trying to order a pizza, but it's incredibly important if you're trying to get access to medical care or something like that. And so not all conversational AI applications is it possible to expose yourself to the risk of being down in the event of a failure. So that's my talk. You can find me on the internet in those places, and you can find me after. Thanks, folks.
So we have time for a couple questions for Jeff.
Sure. Folks in the back? Folks in the back?
So how do you reward an AI? There was a comment to be
Reinforcement learning, right?
Yeah.
Yeah. So it's a paradigm. So it's a sort of nominal semantic that we say that. So the simplest examples are actually just watching an AI play Atari, which is a really fun in general. And so basically all we're saying is the score is how you're getting rewarded, and so that information is sent back. And so it takes actions based on trying to increase that score. And so that's not the same as a class label that says, oh, that was a good go move, because that would require a human to decide what is a good or a bad go move, but rather we're simply seeing, does the score increase? And so games are kind of the simplest way to conceive of that, but you could do that in a transaction concept as well. So you could just say, if you made more money today, I guess you're a smarter AI, and so keep doing what you're doing and do more.
I got a question. You launched in at the first slide, I think it was knowledge, around memory and then forgetting. And I'm just a little curious around sort of, like for forgetting, you could overwrite the knowledge and change it and give it a new piece of knowledge. But then with respect to like learning, sometimes like you were mentioning later on in the speech, concepts can change over time, and I guess I don't have a distinct question, but I'm sort of curious how why did you choose to differentiate forgetting with knowledge rather than Conceptually, I think it seems a little like learning to me.
Maybe. I mean, maybe forgetting is actually just pure policy. So that maybe the result of like in a GDPR context, the user says delete my data, in which that just simply has to drop out. And so in that case, then you should re-trigger the learning process, but it's actually not a function of the learning process. There's actually whole paradigms of both at the infrastructure level in databases, as well as within the machine learning level and within algorithms that are predicated under the assumption that we're going to have all the data forever and continue to learn on top of it. So there's a really interesting recent paper I want to say out of DeepMind is continual learning without catastrophic forgetting. We're actually trying to build systems that never forget things, that always continue to accumulate skills over time. And so this just like fundamentally slices underneath that if we want to say that we as a society don't want to record all data forever for all people.
Yeah, because as humans, we kind of do that, right? We have sometimes we forget things and block it out, but we often are forgetting things and replacing them with.
Right, but we can, AWS is cloud, we can just keep expanding. So, right there?
Yeah, so when you build a conversational model, learning or whatever, is it more common to build like one model to rule them all types of conversation? Yeah, for all types of conversation, even within a specific domain for all users, or would you build a model for maybe each and every one of your customers or each segment of your customers or some sort of combination?
Sure. So the question was about like, do we have one big model or do we slice up by customer type or something like that? In most real-world applications I've seen, any really machine learning system of any kind, inside conversational AI, uses a large number of models in concert. So understanding natural language includes dozens of distinct concepts, which are whole textbooks full of fields of research. And so those are just different models by definition. But then even the user-based segmentation stuff, where you're saying that these users get this model versus that model, it's usually not by user. So if we have different classes of users, we would want to encode that as entity types, right? But where I have seen that being applied is actually, I feel like I'm being repetitive, but data usage requirements across regulatory regimes. So if we have 2 years of data in this context and 6 months of data in this context, because of regulatory requirements, then we're necessarily going to have separate models. And so we're just going to simply have less language understanding in this context. So that's like a common one. There's also folks who will do online experimentation. There's cool frameworks for doing that. And it's increasingly becoming part of cloud-based model servers if you just want to prove out that a given model is superior. I've seen it more in a programmatic trading and ad tech context. I haven't seen that in conversational AI yet, but the principle's the same. If you have a metric to measure performance, you can simply choose at runtime which one's performing better and only promote better models which perform. There's a question there?
So how does the concept of, you were talking at the end about something that sounded like it will require a sanity check if one of the elements in the system is not functioning. Will the system have a sanity check aspect that allows it to be self-aware of it's not complete, it's not working? How will it work?
Right, so this is a huge area of building distributed systems, I would say, in general. And so it's starting to become important to every programmer because everyone's basically building a distributed system, even if they don't conceive of it as such. So understanding how to build reliable software in the presence of software faults is a huge area of research for decades. It's starting to move to the mainstream. And so, to my mind, this is an underserved aspect of how people implement real-world machine learning systems. It doesn't get near enough focus, in part because of the shortcuts we assume, that we definitely have all the users' data, that they're definitely still online, that we definitely got the last utterance. All those things are sort of optimistic assumptions that are much harder to deal with once you actually include them in your problem scope. Like maybe we didn't get the last user's utterance because this speaker didn't pick it up, that the way it worked, whatever the case may be. It's really hard stuff. The short answer is I wrote a book on it, and that's as good as I can do for now. But it's definitely something I think you'll see an increasing focus on within the way that people discuss how to build machine learning systems that actually succeed at scale.
All right. I'm Michael Johnson. I'm from Interactions. Interactions is a provider of AI solutions to enterprise. So what we do are application of speech and language technology for customer care and transactions and analyzing social media and so on. We're sort of a mid to late stage startup, but we have this kind of crazy history in speech and language because some of my colleagues are here from there. A whole bunch of us came into Interactions from AT&T. So we're about 10 plus years old startup that has a heritage in speech and language and machine learning that goes back about 60 years. We weren't all there for over 60 years. So I'm going to talk today about one particular theme, which specifically is a combination of artificial intelligence and human intelligence in different ways, and kind of talk through that and pepper it with different examples from our experience and from others. So, in general, in science fiction and in a lot in the press recently, we have a very bleak view of the potential future relationship between humans and artificial intelligence. I'd like to take kind of a more humanistic look at this, where really I think what we're going to see rather than the Terminator is various different ways in which you have cooperation between humans and artificial intelligence. So, and there's kind of two flavors of that I'm going to go through in sequence here. The first is humans assisting AI. So, in terms of a customer care context, for example, these are settings where a customer, the person interacting with the system, has the perception that they're interacting with an AI of some sort, conversational AI, for example, for an interactive system. But there may be human intelligence being used behind the scenes to assist the performance of the AI. And then you have the reverse as well. We'll go into examples of that, where the perception for the user is that they're interacting with a human. They are interacting with a human, but that human is being assisted by an AI in some way. So going into the first of those, humans assisting AI, kind of in an asynchronous setting, there's a lot of that, right? So human annotation and labeling. So a significant amount of the application of machine learning is based on the availability of high-quality human annotated data. There are also settings where you have humans assisting, think of it as humans assisting AI in terms of post-editing. So maybe you have a system that's doing transcription of medical dictations or whatnot, or translation, and then you have humans coming after that. Increasingly, what we're starting to see, though, we put a lot of energy into, is humans assisting AI in a synchronous setting, where you're interacting with an intelligent virtual assistant, bot of some kind, and human intelligence is being used live in real time to impact its performance. And I'm going to focus in on a specific example of that. So it's actually interesting, given the, we were talking earlier about like performance of speech recognition. It's still the case in real-world tasks, even within specific domains, when you take into account background noise, multiple speakers, people not actually speaking to the system, accented speech, and so on. We're still a long way from truly robust animated conversational speech. We're getting there. We have a long way to go. So if you want to achieve the kind of quality of service that you need, right, for an enterprise, doing customer care or transactions. I'm going to give you an example from food ordering here, right? If you call an interactive system to order food and it doesn't understand you, you call another brand. So it really has to work. So I'm going to play you. This is actually an old call. This is from Hotbox Pizza. It was actually a long ago, early customer interactions. Kind of before we go a lot bigger. So it's an old example, but I like it because it shows you how challenging the problem can be, and you see, what kind of performance you can get. In this case, this is with a human assisted solution.
Thanks for calling Hot Box Pizza in West Lafayette. If you have a question, just ask me. If you're placing an order, is this for pickup or delivery?
Delivery. Delivery.
Go ahead and give me your address, including apartment or street number.
851 David Ross Road, West Lafayette, 47906.
Okay, I've got your name as written and your address as 851 David Ross Road. Is that right?
Yes.
Okay, what can I get for
In
you?
the back of a limo or
2 orders of breadsticks, please.
You get 2 sauces with your breadsticks.
Can I have garlic sauce and ranch, please?
Will that be all before I rebatch your order?
Yes, please.
Any drinks with your order?
No, thank you.
Okay, I've got your order as 2 orders of breadsticks, a ranch sauce, and a garlic sauce. Is that right?
Yes.
you get the idea. So, all right. So lots of not talking to me, background noise, and so on, and the system is able to keep up with that and collect it. Let's just say a little bit about what's going on in that system. So in that case, the caller is interacting with intelligent virtual assistant. There may or may not be speech recognition happening. There are human assistants in the loop that are able to perform speech recognition and language understanding. Actually, Interactions, when they first developed these types of systems, didn't have the top box. It was basically you had a bot that you were interacting with, and then there are human intent analysts which kind of interact in a video gameized environment and are hearing snippets of audio and then specifying intent. So that's what's being used, for example, in the example there. And then basically what that human assistance gives you is a stream of extremely high quality data. Why is it high quality data? It's the data that you get when people interact the way they want to interact, not the way that they think they have to interact in order to get the system to work. So we basically take the exhaust of that process, feed it into the training of speech recognition and language understanding and other components of the system, and do this continuous training and tuning. So just want to give you that as kind of one example of interaction with an AI solution with humans assisting it. Now just kind of twisting to the other angle of in the other direction of AI assisting humans. I mean, there's a lot of examples of this, right? So a vast amount of different applications in data analytics basically involve assisting human analysts with the ability to sort through large volumes of data. Another example I came across recently, I met somebody from Market News. It's a company that is assisting content creators. So you have large volumes of text data on a topic, and rather than doing the full natural language generation problem of trying to create a fluent synthesis of that, they try to identify the key topics that you should cover in an outline about a topic. The assumption is there's a human who's actually doing the writing after that. And in care, you have examples of, we're seeing a lot of different examples of AI assisting human agents and of different types. So one of those is if you were just talking to a financial advisor on the phone, there was one article you can look up here. I'm sure everybody's eyes are moving towards this, but there was Morgan Stanley was kind of an early mover in that in terms of building a system that will predict a good recommendation to give to the investor on the phone, right? And that good possible next best action. So you're interacting with the person that you would with your advisor, but they're being assisted by an AI. And we're increasingly seeing examples of that type of thing in various forms in other types of customer care settings. So assisting an agent in sort of understanding the customer, predictive intelligence there. And another piece is actually suggesting how to respond, right? So not responding on the behalf of the human agent, but helping them with how to respond. And I'm going to show you an example of that. So basically that, you can think of that piece as like, what could you do, how can you use AI to make every agent as good as your best agent, right? So I'm going to show you an example of that from different care domains. So this is social customer care. So social customer care agent is involved in monitoring social media and working out posts and messages that they potentially can respond to for the business. So that could mean identifying selling opportunities. So if you can identify on a social media channel, this is an opportunity to sell, or somebody reporting a particular technical issue or problem. So there's a couple of things I'll talk about here. One is that it's obviously very labor intensive to search and engage with customers over a broad range of social channels. So there's kind of one application of AI there, and then I'll talk a bit about using machine learning to work out ways for people to assist people in responding. So the digital roots technology basically absorbs data from large, the Facebook, Instagram, Twitter, and whatnot, but also like specific forums that relate to a particular enterprise area, ingests that, and basically creates work queues for social customer care agents, right? So it's a social customer care agent working for a large brand. You have X amount of time, you have X number of agents. You don't really want them searching, digging, and trying to find what they should respond to. This technology will absorb all the data and then say, right, you've got time, this is what you should respond to next. This is what you should respond to after that. And then also assist them. And then there's an insights aspect to it as well. So part of that is finding and learning relevant opportunities. So we have an example here where it's identified the fact that something's in hospitality, what the location is, what the person's sentiment is in responding, and then actually suggesting responses. So you can just animate this a little bit. So this is the portal where people are like interacting, doing their social care work. You can see that he's indicating he wants to reply to this person that says, fell in love with this beautiful, we have a bunch of automotive customers. So in this case, I fell in love with this beautiful car, just don't know if I want them though. So that's like a sales opportunity. And the system will indicate potential responses that the agent could make. So it's not responding on their behalf, it's suggesting, and then they can edit or reject and eventually submit a response. So that piece, in terms of the technology, is application of a sequence-to-sequence end-to-end dialogue model. So basically taking large bodies of human-human chat data, we build a sequence-to-sequence model that which will take inputs that people have given and then predict possible responses. There's a little more magic to that, but and then suggest them, and then if the social care agent accepts or edits, right, that's more data that we can use. So it's kind of an interesting application of end-to-end modeling here because of the fact that there's a human in the loop, right? We're talking about AI and human together here because you have substantially less risk there, right? You don't have the same risk of damaging your brand of the system auto-responding with a response generated by an end-to-end dialogue system because there's a human in the loop who can say, oh yeah, okay, this is grammatical or this is inappropriate for this. Just some sort of high-level pieces on that in terms of the filtering of content. There was some analysis you did. We were able to identify a lot more relevant content, able to engage with that with at the same level with significantly less social care staff, and they have an increase in the speed of response. Something that's kind of interesting to me in this one, when we first found out more about it, is that it's very important in social and social responding not to appear too robotic, right? So if you could imagine, okay, in order to do this, if I can identify like a sales opportunity for a particular vehicle, maybe I just have 1 or 2 canned responses that I do. In social, you can't do that because you'll be outed as being a bot, right? So this is not what we want to do here. So the deep learning models here can give you a broad range of responses that are kind of more closely tailored to the customer's request. And as I was saying, I think it's a very interesting fit for doing end-to-end because of the fact you have human in the loop, you have somebody approving the response. So I want to kind of shift a little bit from there. We've talked about the use of human intelligence to assist in artificial intelligence and different possibilities of use of AI to assist a human, and then kind of think of that a little more broadly across the sort of customer journey of interacting with a brand. So the notion of persistence, right? So I mean, really kind of what we're trying to strive towards and do, and what I think you really need to do is talk about telephony first of all, right? So maybe somebody makes a call, they interact with a virtual assistant, they're interacting with an AI solution, there may be humans helping it, there may not. If that call's transferred or if they call again, they speak to an agent, right? We want the agent to be being assisted by the same underlying AI solution, same shared context, predictive models. And then again, when they call again, have that context. And then really kind of, if you look at the way that care is evolving today, you really want to be able to capture that over all different channels and have the same underlying solution. So if the person happens to call, start a conversation over SMS, interact with a mobile device, chat, talk to an agent, interact with in-home devices, being able to have a common AI solution underneath that that's supporting their interaction. And I want to show you just one little, you guys like demos here, right? So one little video around that concept. So what you're going to see here is it's interaction with a fictional insurance company. If you wonder why it's Franklin, headquarters of Interactions is in Franklin. We also have a lot of a technical team in New Jersey and New York and Indiana. They're interacting with Franklin Insurance. You can see the interaction will start on the telephone. Then person gets busy. I'm sure everybody here has had the experience of calling some system and you feel like you have to commit a block of your life to interact with the telephony system, and you make an investment. And then if for somebody comes to the door or a kid starts crying or something and you put the phone down, you lose the investment. So you'll see here switching into another modality so you can come back to the conversation at the other time. And actually it's a little silly, it gets a little silly from there because it's embarrassingly omni-channel. So they go off and interact on Messenger and come back to the phone and continue the conversation, which is more for the purpose of the demo than realism. You'll see the use of switching channels.
Welcome to Franklin Insurance. How can I help you
Staying on
today?
the phone.
I need to start a new auto insurance quote.
What kind of car is this?
BMW 328i.
What is the year of the car?
I actually need to go.
Okay, no problem. If we switch to text message, we can keep going on your schedule. You can message us anytime on Facebook Messenger too. Does that sound good?
Sure.
into conversational SMS here. I'm just going to continue here. This is where it gets a little silly. It's like, I don't like SMS anymore, so we'll go to Messenger just for fun. It's queer, it doesn't recognize them, so it's getting the number. Zip code there, and this is also a little silly. Let's go back to the phone.
How much time do you drive a year?
About 10,000 miles.
Okay, I'll be sending a quote to the email address you have on file. Anything else I can help you with?
No.
You can keep on.
I'll show you one more. I'm going to show you another one of these that's more in mobile and in home and different verticals, ones in food ordering. So this is interaction with another fictional one. In this case, this is our office in New York. Actually, if any of you guys are from X or with X for a while, you know the charging rule office we work very well. So this is a fictional. Our New York office is in that building, and it's right. There's the world seems to want to go outside and have pictures taken with the wolf. So it's a fictional burger restaurant called Charging Burger. It's going to be interactive here. This starts in Messenger again. Actually, there's a few things you'll see in here that kind of tie the talks together too, because you're going to see sort of multi-step interaction and dialogue, but then also reference resolution, picking up things from the existing order, including across channels and modifying them. I want sweet Tribeca burger, sweet potato fries, and a large Diet Coke. Okay. It's come back asking. There's information you need, so it's grabbing like sizes and temperature and stuff like that.
Hey Alexa, ask Charging Burger, what's on the Tribeca burger again?
Cheese triangles, thick cut bacon, pickles, and chives. $13.99.
Free trial set.
Alexa, tell Charging Burgers no pickles, please.
For the pizza, what size do you want?
Large sausage and pineapple?
Got it. Anything else?
Give me a second.
Okay, take your time.
Show my order. Add fresh basil to the large. No. Sure. Correct. Ethan?
Oh, he's following up an SMS to get status. All right. Thank you.
A few questions?
How do GDPR protect out of this?
I should have this slide with we're actually ready for GDPR. So yeah, I mean the usual way, right? So basically the various aspects of our platform have had to be extended recently with get my information and forget my information options.
Was that a very complicated process for you to be able to for action, delete everything? Because this is so many platforms,
right?
So many points of PII.
Right. Well, I mean, I should say, right. You know, a lot of our business today is in telephony and chat for large enterprises, right? So you call Hyatt, it's Interactions. There's a lot of large telecommunication and electronic providers. So we're doing that. Their platform supports that, and for GDPR, then we have to have these properties. So the same thing extends across. It actually relates to what I was saying about if you have the same underlying platform, it's probably going to make GDPR easier, right? Because if all of that data is being stored into the same infrastructure, it isn't patchwork, then you set things up so that you can support those functions directly for all of the channels. But I mean, also some of the things I was showing you here were more, right, I run our research and innovation function, and so I'm kind of showing you not just what we have deployed today in terms of omni-channel, but kind of where it's going. Yeah?
So just it's very interesting the extent of contextual understanding that's been built into this platform so far. I'm curious is, to what extent have you built a system that has been able to intuit that contextual understanding versus how much are you still relying on a human intelligence layer to help drive and support those interactions?
Right. So certainly the second demo there, everything's actually automated. So that's fully SRNA now. That's not actually leaning on human assist, just for there are interesting characteristics of human assist from a deployment and demonstration perspective, right? You need to have people there live, and you need to make sure there's sufficient staffing. You need to be fresh in the interaction. So the human piece doesn't really resolve that problem. That's being handled by the system. So it's more about speech recognition and understanding of norms. Not, how do I resolve this problem? Yeah. That's right, actually, I think I'm going to get you guys in order.
So basically, yeah, it's a really amazing technology, but a lot of businesses are still really slow in adapting it. So how do you encourage businesses to adapt it? Will it be a top-down approach or from an on-up approach?
You mean in terms of like this sales process?
Yeah, sales process, like interfacing it with whatever you do.
Right. So it's a long sales process with large enterprises to deploy these things. I think, I mean, it kind of comes in both directions. A lot of the time it's bottom up from a particular organization, right? So, which may be a care organization or marketing or whatnot that has specific goals that they're trying to achieve. I think we see top down with this now as well, where, you know, the company has had sort of C-level instruction, right? Go and find out how you can apply AI and machine learning to parts of your business. So some of it comes that way. I think that's more recently been the case than before, where it was more like addressing particular problems in care.
Is there algorithm trading called AI?
What's that?
Algorithm trading called AI?
Is algorithm
trading, yes. Market trading using algorithms.
You're saying, is there application of AI to that, or is it what you call it an AI? Well, I mean, the definition I usually work with is you know, artificial intelligence technologies are things where you try and mimic human abilities in particular areas, right? Ability to recognize speech, ability to recognize objects, ability to have a conversation. So, arguably in that setting, right, if you think of what a trader does, and then you have a system that's able to trade on your behalf, and you know, but it's funny because, right, there are things that we do with machines that are not humans have never been able to do, right? So in that case, arguably are those AI. If your definition is that it's doing something. Yeah.
So the diagram, one of the slides earlier, you had shown that after a certain point, when the AI system cannot handle it, transitions to a human being. So let's say the conversation has been going on for 15 minutes, right?
Right.
Would it provide a summary to the human being of the interaction, or how does the human know exactly what has happened, or will the caller have to go over the whole thing all over again from the beginning?
There's different types of and different types of interaction between the, let's call it the ball, right, the virtual assistant here, and humans. Because you mentioned transfer, right? So the human assist that I was talking about, there is no transfer. Almost many of these systems have some type of transfer to a human agent as well. You stay contained interacting with the ball, but it's nudged at certain points, right, through the adaptive understanding mechanism. And yeah, you transfer to an agent. A lot of the time, if that's in a phone setting, through some kind of CTI interface, they're going to get some sort of description of what's going on so far. I think it's an interesting problem in chat, right? It's an interesting summarization and natural language generation problem. Like, what is the right way to present information to the chat agent?
Especially since you showed omni-channel, I thought that would make it even more interesting.
Right. Yeah. If you have that, and also there's two forms of information to present to somebody at the point that the human gets information. One is what is happening right now, right? Let's take like the person doing an insurance quote or ordering food. It's like, this is what I got. This is as much of their catering order as I got. And if the business logic is this is going to be really big, I need to go to a human. How do you present that information? That's one side, that's the right now information, but there's also the historic information. You know something about this person. How often do they interact? What previous information do you have, and how do you present that? So I think there's a lot of interesting applications of various types of predictive modeling and learning, and specifically natural language generation to that problem.
I think Oh yeah, so my question was sort of piggyback on that one. We're creating this front-end customer experience across omni-channel, mediums seems to be pretty standard today. Creating the back end for the agents and the machines, what do you think is the hardest element for you guys of creating that back end experience?
For which? For the
machines. For AI, what do you think the most difficult part is of combining? Is it looking at historical information about the person? Is it the live moment of the interaction and combining that with the historical information?
I mean, they're very different, right? Because you know, the challenges in human assist, right? So you're interacting with the automated system, and they're extremely different. They're all about like latency, right? And latency and scale and complexity of information that the person can deal with, right? When you get to the agent, there's a different set of challenges, right? So you know, I was mentioning one of them, which is like if you're going to assist the person in responding, how do you do that in a way that it's not robotic? So I'm not sure if that's
that makes sense. I sort of threw a lot at you in the. I guess it's how do you maybe ensure a seamless transfer across like the back of information you already have to the current problem, passing on to the agent.
And I think there's two classes of problems there, right? There's the problems which are, okay, what's possible to do in terms of what do I have to predict, how do I present information, and there's infrastructure challenges, which is the boundary between the system that's supporting these 4 channels and the underlying system that agents interact with Forrester and all, or it's a legacy system. And so there's those things that people sort themselves out.
Right.
All right. Thank you, Bob.
I can talk after.
Thank you.